Why do some planets have 4 seasons, some almost none, and others experience decades of daylight or darkness? The answer is not distance from the Sun. It is something far more fundamental: axial tilt.
Axial tilt is the angle at which a planet rotates relative to its orbit around the Sun. This single angle decides how sunlight is distributed across a planet, whether seasons exist at all, and how extreme those seasons become. When a planet has little to no tilt, sunlight strikes it nearly the same way throughout the year. When the tilt is moderate, seasons form. And when the tilt is extreme, seasons become dramatic and sometimes chaotic. Let's begin with Mercury. Mercury's axial tilt is only about 0.03 degrees, meaning it stands almost perfectly upright as it orbits the Sun. Because of this, the Sun stays nearly fixed over the same regions all year long. There is no meaningful change in solar angle between hemispheres, and without that change, seasons simply cannot exist. Venus behaves very differently, but it also lacks clear seasons. Venus has an axial tilt of about 177 degrees, which means it rotates almost upside down and in the opposite direction of most planets. Despite this extreme orientation, Venus shows very little seasonal variation because it rotates extremely slowly and is wrapped in a thick atmosphere that traps and redistributes heat. As a result, Venus remains consistently hot across its surface, with seasons that are technically present but practically meaningless. Earth sits in a rare balance. With an axial tilt of about 23.44 degrees, Earth receives varying sunlight throughout its orbit in a controlled and predictable way. This creates the 4 familiar seasons: spring, summer, autumn, and winter. Earth's tilt is large enough to produce seasonal diversity, but not so large that it destabilizes the climate. This balance is one of the key reasons Earth can support life. Mars has an axial tilt of about 25 degrees, very similar to Earth. Because of this, Mars also experiences 4 seasons. However, Mars has a much thinner atmosphere, so its seasons are more extreme. Temperature changes are sharper, dust storms are common, and seasons last longer because Mars takes more time to orbit the Sun. Moving outward, Jupiter tells a different story. Jupiter's axial tilt is only about 3 degrees, which is too small to produce noticeable seasons. Although Jupiter has violent storms and complex weather systems, these are driven by internal heat rather than seasonal sunlight changes. In terms of seasons, Jupiter is nearly seasonless. Saturn, however, has a tilt of about 26.7 degrees, comparable to Earth and Mars. This gives Saturn 4 clear seasons, but each one lasts over 7 Earth years due to Saturn's long orbit. Saturn's rings also play a role by casting shadows and reflecting sunlight, making its seasonal effect even more dramatic. Then there is Uranus, the most extreme case in the solar system. Uranus has an axial tilt of about 98 degrees, meaning it rotates almost completely on its side. As Uranus orbits the Sun, one pole can face continuous sunlight for decades, while the other remains in darkness. Scientifically, Uranus still has 4 seasons, but they are so extreme and long that they feel unlike anything we experience on Earth. Each season lasts about 21 Earth years. Finally, Neptune has an axial tilt of around 28 degrees, giving it 4 seasons similar in structure to Earth's, but vastly longer. Because Neptune takes 165 Earth years to complete one orbit around the Sun, each season lasts roughly 40 Earth years. Combined with its distance from the Sun and powerful winds, Neptune's seasons are slow, intense, and dramatic. Across all 8 planets, one rule becomes clear. Distance from the Sun determines how hot or cold a planet is. Axial tilt determines whether seasons exist and how they behave. Low tilt means no seasons. Moderate tilt creates balanced seasons. Extreme tilt leads to extreme seasonal behavior. Earth's tilt lies in a narrow and stable range that allows change without chaos. This delicate balance is one of the reasons Earth stands out in the solar system. 8 planets, 8 different tilts, and 8 completely different seasonal worlds, all shaped by a single angle. This is the hidden geometry behind planetary seasons, and this is how the solar system truly works.